Okay, so in this lesson we're going to take this a little further from what we talked about in the previous video, continuing on with composition of functions. Now, in this video we're going to look more at what it really means to find the composition of functions. Essentially what we're doing when we find the composition of functions is we're merging or joining together two or more functions into one. And that's what we're going to be doing today. Now, in the previous video we talked a little bit about some symbols here. Like when we see this F in this little open circle and then a G of X, that open circle represents the term following. So we would read this as F following G of X, which means that we would apply whatever X is to function G, and then function F would follow that. It would come after that. So we'd take that answer and put it inside of function F. And that's what we were doing yesterday. Like yesterday we saw problems like this where we were given two functions, function F and function G. Like let's say F was 4x minus 5 and function G was 2x plus 6. And we were asked to take and find F following G of 2, meaning I'd put 2 inside of function G and take that answer and put it inside of function F. And we concluded that video yesterday by looking at a function machine. And that's what I want to start out with today in this video, is looking at a function machine again. So here I have this function machine showing us what we would do to find F following G of 2. So I put 2 again inside of function G. Function G tells us to take 2x plus 6. So if I put 2 inside that function, I put 2 in for x, and 2 times 2 is 4, plus 6 is 10, so it spits out our answer of 10. And we would take that answer of 10 then and put it inside of function f. Function f tells us to take 4x minus 5, so 4 times 10 minus 5 is 40 minus 5, which is 35. So our final answer there would be 35. So that's what we were doing yesterday. But what if we have a problem like this, where it's f following g of x? So I don't have a number here, so I'm not going to get a number as an answer. If I just have an x inside of parentheses, what I'm going to be doing is I'm going to get an equation as an answer. And that's where this composition of functions comes in. We're going to merge these two functions together. I'm going to merge g of x and put it inside of function f. Because my goal is to take these two separate function machines, instead of having to plug 2 inside of a function and get 10 as an answer, and then putting 10 inside of the other function and get 35 as my answer, I want a single function where I could put 2 inside that function and get my answer of 35 without having to do all these multiple steps. And that's what the composition of functions is going to do. It's going to merge the two functions together. So that's what we're going to look at doing here. We're going to merge, again, what this is telling us is I'm going to take function g and put it inside of function f. Function g is 2x plus 6. So I'm going to replace this x in function f with that other function, the 2x plus 6. So instead of 4 times x minus 5, it's going to be 4 times the other function, 2x plus 6 minus 5. And I would simplify this now. So to simplify this, I'm going to distribute the 4 through. So this is going to become 8x plus 48. I still have the minus 5. Whoops. What am I thinking? 8x plus 24 minus 5. And now I'm going to simplify the 24 minus 5. 24 minus 5 is 19. So my composition of these two functions results in this expression 8x plus 19. So when I put function g inside of function f, I get 8x plus 19. So let's see if this is our magical function that'll spit out this answer of 35. So if I put 2 inside of here, 8 times 2 is 16, and 16 plus 19 sure enough is 35. And you can see that's a lot faster if I have that one composition of the two functions. If I have that one function, it's a lot easier than having to put 2 inside of one function, taking that answer and put it inside of another. So for example, let's say now if I had to find this, f following g of 5. Well, I could do what I did yesterday, and I could put 5 inside of here. And 5 times, or I take 2 times 5, which is 10. 10 plus 6 is 16. So that gives me 16 as my answer. So now I have to put 16 in this other equation. Well, 16 times 4, well, that's going to be 64. 64 minus 5 is going to be 59. So my final answer here would be 59. Now I could do that. That's what I did yesterday. Or now that I know that the composition of these two functions yields 8x plus 19, I could put 5 inside of here, and I should get 59 as my answer. And it's going to be a lot easier, because watch what happens. 8 times 5 is 40. 40 plus 19 is 59. That was a lot faster and a lot easier. That is the purpose of a composition of functions. We're taking two functions, merging them together into one. Let's look at another example. Let's say if I have this time 5x minus 4 is my function for f, and my function for g is 2x plus 10. Well, if I'm asked to find f following g of x, again, I'm going to take function g and put it inside of function f. So I'm going to take my function g, which is 2x plus 10, and put it inside of function f. So instead of 5 times x minus 4, it's going to be 5 times the other function, 2x plus 10 minus 4. So I'm going to start by distributing the 5 through. That gives me 10x plus 50 minus 4. 50 minus 4 is 46, so that gives me my answer of 10x plus 46. And again, I could put 2 inside of this equation. If I had to find f following g of 2, I could start by putting 2 inside of function g. If I did that, 2 times 2 is 4, plus 10 is 14. But then I'd have to take that 14, put it in here for x, so I'd have 5 times 14, which is 70, and 70 minus 4 is 66. Or I could just use this equation that I just came up with, the composition of the two functions. And if I put 2 inside of here, 10 times 2 is 20. 20 plus 46 is also going to give me 66. So you can see that it's a lot faster oftentimes to use the composition of functions to figure out some of these values. Like, let's look at the next one. The next one looks very similar, but if you notice, it's switched around. This time I have function, I'm going to put function f inside of function g. So I'm going to take my function f, which this time is 5x minus 4. I'm going to put that inside of function g. So instead of 2 times x plus 10, it's going to be 2 times 5x minus 4 plus 10. Well, when I simplify that, distribute the 2 through, well, that's going to be 10x minus 8 plus 10. When I simplify the negative 8 plus 10, I get 10x plus 2. And there's my composition of those two functions. Now, if I had plugged in, or let's say if I had to find g following f of 2, I could do what I did yesterday, put 2 inside of function f. Well, that's going to take 5 times 2 is 10, 10 minus 4 is 6. Now I have to put that 6 over here in function g. 2 times 6 is 12. 12 plus 10 is 22. I got my answer, but it took me some time. Now that I have this composition of the two functions, the 10x plus 2, if I put 2 inside of here, 10 times 2 is 20, plus 2 gives me 22. So again, you can see the benefit there of finding the composition of two functions. Again, what we're doing is we're joining, we're merging two functions together to come up with one single function to get our answer in just a matter of a step here. So that's it for this video. So again, and the purpose of this video is again just to show you how to find the actual composition of two functions. So hopefully that'll help on your assignment. So with that, good luck.